Hi everyone, welcome back to the GRE crash course. In this video we're going to start in on the quantitative section, and particularly we're going to be looking at quantitative comparison today. So considering the quantitative section, just like the verbal section, you're either going to see two quantitatives and three verbals, or the three quantitatives and two verbals, and you do get a little bit more time here. You get 35 minutes for the 20 questions as opposed to the 30 minutes for verbal. The question types are broken up into really three different types, maybe more, maybe less, depending on how you want to look at it. But the one thing that nobody will disagree with is that the quantitative comparison is a unique type of question that you have to be prepared for the GRE. Beyond that, in the videos to follow, we'll look at some of the other questioning styles that they have, but this is definitely one of the most important. From my experience, the quantitative comparison questions are always grouped right at the beginning, and you can expect to see about 7 or 8 of them. So out of the 20 questions, you're going to start with that quantitative comparison, and you can see that the data interpretation section will come usually in the back half of the test, and the rest of the questions are sort of general, pick all that apply, multiple choice, which we'll be looking at in subsequent videos. Just a note before we jump in, this video and the other videos in the crash course are not meant to teach you the math so much as familiarize yourself with the GRE, the way in which they set up their questions, and develop strategies for those types of questions. So that being said, I'm going to be pulling questions from all different areas, but if the particular math concepts are something that you're struggling with, this is not going to be a place where I'm going to go too deep into the explanations. Most of this is going to be, again, dedicated just to the strategy. To start off with, let's just familiarize ourselves with how this question is going to look on the test. So to begin with, this little mock-up is just something that I made, but it looks like the test as you'll see it. At the top, you have the calculator button, which when you click it, a calculator will show up on screen. It does have some severe limitations. It caps out at 8 digits, and it also doesn't have exponents. I would say those are the two big limiting factors. Other than that, it's quite good for questions when you're just dealing with basic arithmetic that you don't want to have to do, or square root. But otherwise, I'm going to try to avoid using the calculator as much as possible in this series of videos. You can mark questions you intend to come back to, you can navigate forward and backward, and it'll give you the information. It'll tell you what section, what question, and how much time you have left. Quantitative comparison, in particular, has a very distinct setup. So sometimes there'll be some information up here or a question of sorts, which we'll see in other questions, but what you can always count on there being is quantity A, quantity B, and those quantities listed underneath, and then these four options, which will always be the same. The first one, quantity A, is greater. The second one, quantity B, is greater. The third one, that the two quantities are equal. Or the last one, that the relationship cannot be determined from the information given. So these four answers should be things that you become so familiar with that you don't even need to think about them. They should be memorized. It should be automatic. So to solve this particular question, we would probably just do the math. You could punch this in the calculator, try to do it in your head. Eventually you'll get that quantity A is equal to 64, where quantity B is equal to 86. Of course, 86 is greater than 64, so we would just click on quantity B is greater, and that would be that. Let's take a look at just one more sample problem, and this is the type of question that you could actually see on the test. So it tells us in a decimal number, a bar over one or more consecutive digits means that the pattern of digits under the bar repeats without end. For example, 0.387, right, would just repeat 387, 387. And a lot of you probably already know this. This is a common mathematical convention. So it doesn't really help us that much in the question. If we look at quantity A and quantity B, they look similar, and if we only just think, okay, so this one goes 717, but this one also goes 717. But of course, if you write it out far enough, eventually you'll see, right, 717, 717. So the fourth decimal place is going to be a 7, whereas over here, 7171. So of course, A is greater than B, and we would select that one. With the two questions we saw first, both values were fixed. We were able to just evaluate them and indicate which one was greater. It isn't always going to be the case. Oftentimes with these questions, you'll run into variables with either one or both of the quantities, and I find that this is one of the easiest ways to break up quantitative comparisons and change your strategy depending on what you're looking at. So to begin with, let's take a look at the strategies when you're dealing with a fixed value versus another fixed value. Go ahead and take a look at this question, maybe pause the video and try to solve it yourself. So in this case, even though the quantities are variables, we have A and B, the variables themselves do not change in value. There's only one value for A and one value for B, and so we know we're dealing with fixed versus fixed. Because in this case we have a linear equation and we're looking for missing coordinate pairs. So in this case, A would just be the x value when y equals 0. So we could plug in 0, solve for x, and B, likewise, we could plug in 0 for x, solve for y, and we'll end up with quantity A being negative 20, quantity B being 10. Now, even if you didn't solve it this way, or perhaps you're given an equation that just seems like it'll take a long time to solve, you also could have just estimated, right? In this case, if you're familiar with graphing y equals mx plus b style equations a lot, you'll notice that it has a positive y-intercept and a positive slope. So it's going to look something like this. And so we know that quantity b, being the y-intercept, is going to have to be positive, quantity a is going to have to be negative, and that's enough to just let us know that, of course, b is greater than a. A common mistake that I see people make on questions like these are picking an answer like D. You should never pick D if you recognize that the two quantities are fixed and that they only have one value. In this case, even if you didn't know how to solve it, perhaps you recognize that this is an equation and these are coordinate pairs, so there's only one value for A and one value for B. They have to have some sort of relationship to each other. Either one is greater than the other or they're equal. So at the very least, you can, again, up your chance of guessing the right answer by just ruling out D in a situation like this. Let's take a look at another question like this. So go ahead and try to solve this, and if you are using a handheld calculator, do not just punch these values in. Keep in mind the GRE calculator is not going to be able to give you any kind of meaningful answer with these quantities. So in a case like this, we can't really solve the quantities. There's no easy way to evaluate 7 to the 100th power as whatever it would be. Likewise with 50 to the 50th. So what we need to do is find some way to either estimate these values or find some way to make the values comparable to each other, just so that we can see which one's greater. And one of the easiest ways to do that is to do some math and say, well, I know that 7 to the 100th can be rewritten as 7 to the 2nd to the 50th, and 7 to the 2nd to the 50th can be rewritten as 49 to the 50th, which is of course less than 50 to the 50th. So the guiding principle here is like finding a way to make the values comparable. In this case, trying to get the exponents equal to each other. And so, of course, with that in mind, we know that B is the answer. Again, though, with a question like this, even if you don't know how to solve it, even if you can't find a way to make them comparable, you would never pick D, right? Obviously, 7 to the 100th and 50 to the 50th, they're going to end up being whole number integers. And so one either needs to be bigger than the other, or they need to be equal. The next type of question which you'll encounter is when one of the quantities is just a fixed value, while the other one varies. And in a case like this, the best thing you can do is take that variable value and try to find how high it goes, how low it goes, right? Find the maximum and minimum value for that variable in its range, and never pick C, right? A singular value can never always be equal to a range of values. So let's take a look at some of them. So with this question here, the first thing that stands out to me, right, is that quantity B is a fixed value. It's just 60 pounds, whereas quantity A says the average weight of all 40 animals in the zoo. Now you might be thinking, okay, average weight, that's just got to be one number. However, in this case, we aren't told what the animals weigh exactly. We just know that each of the animals has a range of weights. And so here we are looking at specifically a fixed value versus a variable value. Now, one of the issues that I see a lot of people run into is that they aren't deliberate about how they solve for quantity A. Because, first off, we can't solve for quantity A, but that doesn't mean the answer is D. What it means is that we should figure out, well, how big can quantity A be, and how small can quantity A be? So let's try to figure out what that largest value would be for quantity A. So let's say that, so we have 25 mammals, and let's say each of them weighs the most that they possibly could, 50 pounds. That's going to come out to 1250. And if we have 25 mammals and there's 40 total animals, there are going to be 15 non-mammals. And again, let's assume that they all weigh the most that they possibly could, in this case 80 pounds. That's going to total 1200. And so if we add our two values together, what are we going to get? 2450. And so if this is the total weight of all the animals in the zoo, if we want to find the average weight, we would just divide it by the total number of animals, in this case 40, and we'll find that the average weight is exactly 61.25. So what does this value mean to us? What is 61.25? That's the largest that quantity A could be. And in that case, A would be greater than B. But this is the place where I find people have a misconception. This does not mean that you pick quantity A is greater. What this means is that quantity A could be greater. But if we look at our possible range of values, of course, if all the animals weighed 40 pounds and 20 pounds respectively, the average for quantity A would be way less than 60. And so A could be greater, but it could also be less. And so of course, that means that the only option we have open to us is the relationship cannot be determined. Another note here, the average weight of the 40 animals is probably going to be less than 60, right? Like if this were an actual real world situation, but that doesn't matter. In this case, we have to take into account the extreme that all the animals weigh as much as they possibly could, and the average ends up being greater. And so we just don't know. Let's take a look at another variable value versus fixed value and go ahead and try to solve this one. So with questions like this, I find that people have a tendency to just pick the central value and solve. So here you might pick 11.5 for x and then choose like 3 or 4 for y. And there's nothing wrong with that. It'll give you a relationship to begin with, but you still are going to have to think, well, how large and how small can quantity A be? So let's try to jump straight to it. So what's the largest that quantity A could be? Well, we would want to make the numerator as big as possible, so something like 12, and the denominator as small as possible, 2, which would give us 6. Now, quantity A can't be equal to 6, but it can be anything up to 6, right? We could have x being 11.999 and y being 2.001 or something like that. Then we want to go ahead and solve for our minimum value, and we would have a numerator of 11, a denominator of 5, and our lower bound for x is going to be 2.2. So a way of thinking about this is we know that our quantity A ranges between 6 at the upper end and 2.2 the lower end. And so of course quantity B fits inside of that range, and so our answer is definitely going to be D. So with this method, you should only have to solve for two values for the variable quantity. And it seems simple, but I think the problem that I find students run into is that they attempt to pick at random. And so in a case like this, they think, well, maybe I'll just pick 11.5 and then 3. And then I'll try 11.5 and 4. Maybe I'll try 11.8 and 2.1 or something like that. And they keep moving back and forth at random. And you don't want to do that. You're wasting time that way. You want to immediately go to, well, let me just drive quantity A as low as it can go, and then let me try to push it up as high as it can go. The last and third type of quantitative question that you're going to run into is when both sides are variable values. And the strategy here is going to be similar to the one we just went over, except we don't have the luxury of just being able to push one value up and down while the other one stays put. What tends to happen is that as you change your value, both sides fluctuate, and so it takes a little bit of a different approach to make sure that you're being thorough here. So let's take a look at this question here. So right away, we see that x can't be equal to 0, but quantity A and quantity B both contain an x, which means both of our quantities are going to vary, and depending on what we pick for x, it's going to change both quantity A and quantity B. So it doesn't make a ton of sense to try to just say, oh, I'm going to make A as big as possible or A as small as possible, because quantity B is also going to change along with it. So the easiest thing we can do here is to just start by picking a value like 1. And what 1 is just an easy value to work through. So in this case, we have the absolute value of 1 plus the absolute value of negative 2, which is going to be just 1 plus 2, which is just 3. And then over here we have the absolute value of 1 minus 2, which is the absolute value of negative 1, which ends up just being positive 1. And so we find a relationship where A is greater than B. Now, the silliest thing you can do at this point is just pick A and move on to the next question. This is something I see people do, and it's just flat out wrong. What you've done by showing that quantity A could be greater than quantity B is you've eliminated that quantity B could be the greater quantity or that they are equal. Because you've shown that at least in one case, A is greater than B. But what still remains is quantity A always the greater quantity, or is the relationship undeterminable? So now our goal becomes to try to find a situation where A is not the greater quantity. Whether that means they're equal or B is greater, it wouldn't matter, because we could just show that A isn't always greater. So let's go ahead and pick another value. And let's not just pick another small positive value. I see people do this, and it's not the right thing to do. Once we've picked one, it doesn't make sense to pick 2 or 3 or 4, because they're probably going to behave the same. In this case, I know I'm dealing with absolute value, and so what acts a little differently with absolute value would be negative values, right? So here, let's try -1. If x is -1, we're going to have absolute value of -1 plus the absolute value of -2, which is going to be 1 plus 2, which is equal to 3. Over here, -1 minus 2 is going to be the absolute value of -3, which is also 3. And so we have found that when x is equal to -1, the two quantities are equal. So now if we return to our options, is quantity A always greater? No, right? We found a situation where the quantities were equal. And so what that means, again, another mistake I see people make is they just settle on whatever the most recent answer they've come up with. It doesn't mean that the quantities are equal. It means that the relationship cannot be determined, right? Because if sometimes quantity A is greater and at other times they're equal, the only answer that makes sense is this last one. Let's take another one with variable values. Go ahead and try your hand at this one. So I think some people will probably just look at this and be able to sort of abstract which one's going to be greater, P or Q, just based on the percentages. But let's work through it just to make sure. So what we might do is pick a value for P that would be easy to work with. And I'm going to pick 100. I think 100 is probably one of the easier numbers to work with when you're dealing with percentages. So if P is equal to 100, we know that 12%, so 0.12% or 0.12 times P is going to be equal to 15% of Q. So in this case, we would divide both sides by 0.15. And what do we get? So if we just punch this into the calculator, we find that Q equals 80. And so in this case, again, we have found A is greater than B. Now, let's review what that means exactly, right? It doesn't mean that quantity A is the greater value all the time, but we can safely eliminate choices B and C, right? Once we know A is greater, there's no chance that they're always equal or that B is always greater. But again, how do we know which one's correct, A or D? And one of the mistakes I see people make is that something like this, they think, oh, but plainly, obviously, no matter what I pick for P, it's going to be greater than Q because 12% of P equals 15% of Q. In this case, though, what if P was equal to 0? Well, 12% of 0 is 0, and 15% of 0 is 0. And if P or Q happen to be 0, the other one would also have to be 0, and the relationship would be that they were equal, which means quantity A is no longer the greater value, and the answer would have to be D. Now, with both the two questions that we've seen so far, the process has been pretty straightforward, right? We've been able to pick a value, eliminate B, eliminate C. We've been left with, well, is A always greater? We find a situation where A isn't greater, and we know 100%, we are positive D has to be the answer. Unfortunately, it doesn't always work this way, because what if you continue to try values and you keep coming up with the same relationship? So if I change this question just a little bit and add the stipulation that P and Q must be positive, well, we can still try 100 and eliminate B and C, and be left pondering, well, is A always greater, or is there some situation where it's not? The problem, though, is that as we try other positive values, we're going to find that A is always greater than B. At a certain point, though, you have to stop and say quantity A is always greater than quantity B. And that ends up being the right answer here. And part of it's because at a certain point, the pattern should show itself, right? You should be able to abstractly say no matter what positive value p is, if 12% of it is equal to 15% of q, p has to be the larger value. So it doesn't give you that same confirmation that the other questions did, where we were able to eliminate 3 wrong answers. But the reason this method is so effective is because by starting off with the easiest value, in just a matter of seconds, we've eliminated 2 wrong answers. And so these questions are, at worst, they're a 50-50. And then by being thorough about the numbers that you choose, you try to eliminate one of those last 2 options. And if you can't, then you should settle on it. And if you can, then you know the answer is D. In the future, we'll look at some of the common traps that they set on quantitative comparison and what numbers to be testing. There are definitely distinct patterns to this type of question that you want to be familiar with. But the short list, just to make sure that you're being thorough with the values that you choose, try 1, try 0, try -1, try fractions. Um, Large and small numbers, so this means just like large positive and large negative values. Sometimes picking 100 or picking -100 is the easiest and most efficient way to sort of break the relationship you found. And then also there are certain questions that just leave clues in the question. So for instance, if they keep using the number 7 over and over in these equations, you might want to just try 7 to see if it behaves differently. And this concludes this crash course video on the quantitative comparison section. The best thing you can do with this information is put it to use. You really want to get into some practice material, try to identify quickly what type of question am I looking at, what kind of technique can I use to solve this question quickly. So in the next video, we'll be going into other types of questions on the quantitative section. So thanks for watching, and I hope you'll join me next time.